All right, we're starting up with a warm-up for task number 2, so go ahead and pause the video and make sure you give yourself a chance to try these out. Okay, so you should have had a chance to try these out. The top one is using properties of logs. So we know addition here, that is multiplication, subtraction is division, and we also know that these numbers out front represent exponents. So first step, maybe you just want to put those exponents in there, giving you log 4 plus log x squared minus log y cubed minus log 5. All right, so I'm going to start by just saying that this is multiplication because of the addition. So this is the product property. So I would get log of 4x squared for these two terms. And then I just go in order from here. So this is division. So then that's all going to be over y cubed. If I wanted to do this in 2 steps, then I still have that. So I have log 4x squared divided by y cubed. And now this is division again. So I'm going to have log of 4x squared divided by 5 and y cubed. You could have got that straight from there. I was just showing an intermediate step, as sometimes this is kind of hard to figure out what it means to have 2 divisions in a row. But it just means that these two are both being divided by whatever came first. All right, now the second warm-up is just review from task number 1, where I have a log base 10 equation that I need to solve. And so to undo it, I'm going to do the inverse. So if it's base 10, then I need to use 10 to exponentiate both sides. So when I do that here, those cancel out because they are the inverse of each other. This gives me 3x minus 1 equals 10 to the first power. It's just 10. Now I'm going to add 1 to both sides, giving me 3x equals 11. Divide both sides by 3, and my exact answer is 11/3 for that problem. So then let me zoom out again, so in case you didn't have a chance to see both of these problems, then you can take a moment, pause, and copy them down now. All right, so I combined these as warm-ups because today we're using, or for task number 2, we're using properties of logs and this process of undoing using the inverse. We're putting those together. So you can see here that I have log in 2 places, and so it's your key to yourself when I don't just have log in one place, because I can't solve for anything unless I'm isolating it, that I must need to use the properties of logs in some way. And so since these are both log base 10 and we have addition, we know that log of x minus 3 is really being multiplied by that x over there because it's the product property. So first step would be to say, okay, it's x times x minus 3 equals 1. And then I can just distribute that to make it a little easier. So I have log of x squared minus 3x, and all of that equals 1. And now that I have log in just one place, now I'm going to undo just like I did with task number 1. So since this is base 10, I'm going to say it's 10 to the power of on both sides. If this was base 6, you would do 6 to the power of on both sides. You would undo using the same base. So these undo each other. And this gives me just x squared minus 3x. And over here, this 10 to the first power, that just gives me 10. So hopefully right now you're all thinking, this kind of looks like a quadratic. And it is. So to solve a quadratic, I need to subtract the 10, get all my terms on one side, and have it set equal to 0. And then I can say, is it factorable? Are there two terms that multiply to be negative 10 and add to be negative 3? And yes, there are. So we have x minus 5 times x plus 2 equals 3. And then if I set both of those terms equal to 0 and solve for x, I get x equals positive 5 and x equals negative 2. Now, remember the term extraneous. One of these two terms is extraneous. And we would be able to tell that by plugging it into the original equation up here. Try doing this at home with your calculator. Try putting log of 0 in and tell me what you get. So log 0. Ooh, I get an error. It says that error domain means 0 is not in the domain. Try doing log of negative 1. So log negative 1. So I know I can't take log of 0. Oh, also, this gives me a non-real answer. So it's also not in the domain. And so one of these answers, if I plugged it back in up here, would give me a negative, and it's not in the domain of a log. And you guys can go back and look at your log graphs to know what I'm talking about when I say the domain. So we're just going to plug them both in and see which one is extraneous. So if I put 5 minus 3 in here using my x equals 5 and log of 5 equals 1, then I don't get any negatives when I do this. And I can check my work. I can go further. 5 minus 3 is 2. Log of 5 stays log of 5. This means multiplication, so I get log of 10 equals 1. Is that true? Well, if I rewrote that in exponential form, since this is an understood base 10, 10 to the 1 equals 10. That is true. So x equals 5 works. So we like this one. I don't even have to go as far as that with the x equals negative 2, because when I plug that into my original equation, right here, these give me negative logs. And so I would have to say that this one is extraneous. So there is my complete work for that. Go ahead if you want to pause and copy anything down you might have missed. Next page will be for you to practice. So just get ready to pause this. We have two equations here. Not all of them will give you an extraneous, but if you've got anything that would give you a negative, just make sure you note that that could not be an answer. So go ahead and pause right here, and in a moment we'll come back together and do this one together. All right, so again, we're using some properties of logs. So this negative here, this means division. So my first step on A might be to have log of 6 divided by 3x. And this is still log base 10. I want you to note that. And I'll zoom in a little bit. And now to undo this log, I'm going to use 10 to exponentiate both sides. And that undoes this side, giving me 6 over 3x equals 10 to the negative 2. Well, what does 10 to the negative 2 power equals? You can say it equals 0.01, or I know that if I move this down, I get a positive. So 6 over 3x equals 1 over 10 squared, giving me 1 over 100. Now we could cross multiply because we have two proportions set equal to each other. And that would give me 600 equals 3x. Now I divide both sides by 3 and I get x equals 200. And I'm pretty sure that that is not extraneous, because if I look up at the top of my equation, if I plug in 200 for x, it doesn't give me a negative. So this is okay. It's not extraneous. All right. Last problem for this week before you guys finish up, do task number 2 and then an exit ticket. Again, we have some division. So I have log of 2x squared divided by 5 equals 1. Again, it's log base 10. So 10 to the power of on both sides. These undo each other, giving me 2x squared divided by 5 equals 10 to the first power, which is just 10. So again, I can use cross multiplication. I can set that 10 up to be a fraction. So I have two proportions equal to each other. So I can multiply like this. 5 times 10 is 50. 2x squared times 1 is just 2x squared. Divide both sides by 2, giving me 25 equals x squared. Now to solve for x, I'm going to undo the square by square rooting. And don't forget here, this gives me a plus or minus 5. But can both of those work? So we would have to plug them into our equation and check. If I have log of 2 times 5 squared minus log of 5, that doesn't violate anything. I don't get any negatives. And then I try it again with the negative 5. And negative 5 squared also gives me a positive. So both of these answers work in this case. Right, so there's that problem, so you guys can copy it down. All right, again, make sure you're asking questions. I try to get back to you within an hour or two. Just let me know what questions you have this week, and I will see you next week.